Hi, it's Gadget UK here again. This video is sponsored by NordVNP. Yes, VNP, not VPN. Very nice people, very nice Nordic people. Stefan in Denmark kindly sent this over to me. He thought I might be interested, and boy was he right. Just looking at those pens, look a bit bent there, don't they? Yeah, it's a turbo card, you know, an accelerator. Tornado is the model, I want to say. It might be the make. It says BS there. That's what you get from my channel. Yeah, if you just pull this off, you can see it goes into a 68K socket, and it's got 16 megahertz, 68,000 here. ST branded that. We've got room for an FPU, and Stefan kindly bundled this with it, so that's going to be cool if we can get this up and running. And straight away, you know, you're like, well, there's something missing there. So yeah, I was a bit concerned about that. But if you look at the traces, it's like one thing goes to it up here, and then one thing goes down here. There's nothing in it. I don't know if that's like for configuration points. You could stick wires across there maybe when testing or something. I don't know. I mean, it just seems to go to that jumper and that's it. So I don't think anything's really missing from there, although one or two of the pins look a bit bent in that, as if something was in it previously. Yeah, coming back to the main things here, so we've got a couple of GALs here, 7.4 series there, a couple of RAM chips, 8K each, giving us a 16K, so that's the first thing that caught my eyes actually. I was like, that's interesting. And something here, I don't know what that is. Is that a ROM? Is that like a CPLD type thing in a dip package? I don't know. I'm thinking ROM actually, but I could be wrong. Yeah, so the thing with the RAM, and I looked at the specs, well, there's very little information on this. It does say though in the specs for this, it's, you know, accelerator card, 16 megahertz with 16K cache, and that's the thing here, cache. We haven't seen a CPU card with any cache yet. This is the first time I'll have seen one of these for an ST or Amiga that's got cache on board. So, you know, my first thought with that was, it's about weight states, isn't it? This is 16 megahertz. When it needs to interact with the Amiga side, RAM access and stuff, well, it's going to have to clock down to 8 megahertz. Well, it's not 8, is it? 7.09 or something like that, isn't it? And even though this is rated 16, it's probably not running at 16. It probably runs at 14. And in fact, I now look at the board, I'm wondering where it gets this clock from, actually. Is that for the clock? The crystal? That could be for the crystal, actually, now I think about things. That would make sense, wouldn't it? With just the corner points connected there. Yeah, that's what that is. That is for a crystal. That's perhaps why this isn't running at the moment. So maybe it will run at 16 megahertz, thinking about it. But in any case, the whole thing about weight states, if you don't have to access the main bus there, you know, to request access to RAM, etc., and have some weight states as it drops down in speed, well, everything runs full speed, doesn't it, when it can just take it from here. So in order for that to work, well, there are a few things. 16K, it's not very much, is it? What can you put in 16K? Well, you can't cache the ROM, unless that's like a ROM. I don't know, you can't cache the ROM in 16K. Then we're into the realms of RAM, right? So when you read from RAM, well, to start with, this is not initialized, is it? So you need some way of keeping track of whether you've actually got anything in that RAM to read without having to hit the bus. So that's interesting. Is this maybe a cache controller or something? That's what that could be. The idea being, you see, let's say you do a read, I don't know, 2K a day, you've read it. At the same time as read, it could be right into this. So the CPU's reading, it's been written to this as it's read, and then writes, yeah, they come to here and out to the motherboard. But then when it reads again from the same addressing, you know, it needs the same address range, doesn't it? You've only got 16K here. Then it doesn't need to hit outside the Amiga. You can just read straight from here at 16 megahertz or 14 megahertz or whatever it's running at its full speed. So I think that's the whole idea behind the caching. You can't cache writes, obviously, because if you cached, you know, if you wrote and it gets cached here and it doesn't go to the motherboard, well, something's not going to get a write somewhere. Your main RAM is not going to reflect this RAM. So, and that's the next issue. RAM in the Amiga can get written to by other things, can't it? Chip RAM is the example of that, where, you know, the chipset writes audio and file data as Paula reads, you know, from a floppy drive, etc. That gets read and written to chip RAM. So how does that work? I don't know. And what 16K gets cached? I don't know. Does this keep track of what's cached, which addresses? Maybe that's what that is, because you can't do it with ease, that's for darn sure. There's nowhere near enough equations or pins and things on these to be able to have like some sort of cache management system. These are just going to be for, you know, doing what I just described there, you know, dropping and increasing the clock speed at the relevant points based on, you know, some address decoding logic there. So that must be some sort of cache controller. Can't see what else it could be, really. So there's a couple of factory wires on here, look. It isn't in too bad condition. There's obviously little marks and things around there like that. Some of the connections do look a bit oxidised under there, you know, like some moisture or something perhaps has got on some of those pads. Not the actual things here, the actual wires below. So I think we'll just have a go at powering this up straight away. I'm going to go get an Amiga 500 motherboard. We'll go with a Rev 3, I think. And we need to use probably Kickstart 1.2 or 1.3. I'll just see what's on the board. It might be 1.2. Yeah, you can see why I said sponsored by Nord VNP now. Very nice people. Because this actually came from Stefan as well. I fixed this back in 2019, just after I lost my job actually. And Stefan kindly sent me a couple of these pretty borked Rev 3 A500s. So anyway, let's just get the CPU out. In fact, let's not do that. Let's just power it on and make sure it works. Always make sure you've got a level playing field before you start. There we go. So it's Kickstart 1.3. Yeah, so I reckon it'll work with 1.3, but you know what? We might need to swap to 1.2. I've got 1.2 if we need it. One of the problems with this here, can you see how short the pins are? They're really short. I've never seen turn pin pins so short. And of course, which way is this going to go round? Is it going to interfere with things? Well, it is, isn't it? You know, pin 1 on these is down here. If pin 1 is, then that means it's going to go like that. Well, how on earth could you fit that in your A500? That's a bit crazy. So I'm guessing it's remapped, and we could test that. Just to put that down a sec. So if we look at, well, let's put it up this way. We've got pin 1 down here, yeah, and I'm guessing it's going to be up there. It isn't. Does it go down here? Yes, it does. That's got to be the most ridiculous upgrade ever. Why would you have it that way? I wonder if someone's took the CPU out, you know, and put it in the wrong way. It's all very well it's saying pin 1 up here, but was it originally round that way? Yeah, the next thing to do actually is just test VCC. We have a 7.4 series here, so from memory I think grounds and VCC maybe in the middle somewhere on one of these CPUs. So let's just test that. Let's see if we can. We'll do the ground first. Let's go from ground there. This could also be one of these boards that's got a separate cable for VCC and ground. Oh no, there it is. So we've got our ground, and it's up on the same side as pin 1. It's past the sensor, so if we test from here, hang on, I need to try and get a ground, don't I? Ground on one of those 7.4 series there, so it should be up here somewhere if that was the ground. It's not, it's in the middle where I thought it should be. So, I don't know, there's something weird going on with this, for certain. It was up here. Let's just test up here. No, there's no ground there. Ground there, that's not the middle. That's not the middle. I think that that's a VCC actually. So let's just test from there to VCC. Yeah, that's a dead sure. So, do we have VCC where ground should be? It seems that way. Let's just test on this board here from VCC on a 7.4 series to over here. Yeah, right. Now I'm really confused. Maybe there's some adapter to flip that the other way up. Because VCC, yeah, is on the left side according to pin 1 of the centre, yeah, and I'm pretty darn sure that ground is on the opposite side. Yeah, so my recollection was correct there. VCC on that left side there, ground on the right side there. That is not what we're seeing here at all. Yeah, that would appear to be our VCC. Maybe this chip's upside down. Maybe that's what it is. But I mean, how did it get out of the socket? I don't know, maybe someone took it out because it wasn't working. In any case, we're going to go with logic here, as in, you know, 5 volts and ground. we know those are certain in relation to 742s on here. Yeah, 2 more chips under there. 2 more gals, actually. Anyway, now that's off, let's just do our test again. Well, let's assume it's going to go in a sensible way, that way around, which would mean, I think we just confirmed this, that VCC is over here. Yeah, I put it on ohms just to make double sure. Yeah, 2.2 ohms, I'm pretty sure that's correct, which means the pin over here should be ground. And this is the thing, it isn't. Why is it not ground in relation to that? And I could have sworn these gals had the ground on the bottom right there. Yeah, that one does. That gal does there. So its ground is correct. This gal here isn't. Maybe there's a fault with this. Maybe the ground rail's blown open or something. Maybe because someone had the CPU in the wrong way around. Or corroded trace. So anyway, we've certainly got our work cut out for us right at the start here, in terms of trying to understand what's going on with the ground. Yeah, there's a few scuffs and stuff you can see around here, look. And there's a few sort of corroded-ish looking wires and things. So I'm just going to spend a bit of time inspecting this, I think, and I'll report back. Right, I can't find the broken connection wherever it is. It's going to be under something. I'm not removing everything. I'm just going to take an educated guess here. If I test, say, between the ground on this and here, we've got grounds on those, yeah? Bottom corner here, usually on these gals or pals. That is one, isn't it? Yes, it is. It's a GAL 20 V8. Yeah, the grounds are joined up here, but those aren't joined to this one. Yeah, I've not checked these because I don't know the pin out is, but I'm guessing there's a break between one side and the other. So by virtue of joining the ground on this to the ground on that, then all the grounds should be joined up. That's what I think, and I can test that. We'll beep around just to make sure we do have a ground on these 3 chips here. These 2 are also isolated at the moment with their grounds. Yeah, and this is, you know, the mystery. I've put some little red marks on here, can you see that? Just so that I don't lose track of where the ground is while doing these measurements, but look, there's no join. If I test them to each other, they're joined. So those 2 seem to be somewhere where the break is, before it goes over here maybe, or something like that. You know, I don't think disconnecting grounds would be any kind of logical way for anyone who was capable of designing something this sophisticated as a feature, you know, an option. So I think we've got a break. So I am going to join from the main ground over here. I'm going to take it straight from the CPU socket, if I can work out where it is on here. Well, we know it's that one there on this bottom corner here on the GAL. So let's just join it up. Now, all of this damage could have been done, well, I say all this damage, the damage there on the ground could have been done as a result of having the CPU in the wrong way, or someone sticking the socket and the CPU in the wrong way at some point. Maybe the CPU's dead because it's been in the wrong way. Right, that's that, it's joined there. So, what I need to do now is just confirm that again, and I'll show you again here now. We've got to assume these are in the right way. These haven't been swapped around. Like maybe the CPU was right and everything else has been flipped around. I don't think so. So from there to say, I don't know, down here. Hang on, there's the ground on that one. There you go. There's no join, see, and there's no join here. So I'm going to take it to that one over there. It's just more of a straight line than coming right down here. I could take it to here. Tell you what, let's do that, that's even easier. So from this 742 here, from its ground, let's just have a probe on these edge ones. You never know, it might look out somewhere up here. Unless this is disconnected as well. No, look there. So 3rd from the end here, we've got a ground. So as I flip it up, it's 3rd from that corner there, just where that blue wire is, unfortunately. Let's just move that blue wire down. There's a chance one of these is a ground, but I've checked those and they don't seem to be. Anyway, let's just pull that over. Wants to go over here. I'm going to give a bit of flexibility on it. Trim it there. And that should be it. Hopefully, all our grounds now will make sense. So I've just soldered it away from the ground on the GAL there to there, you know, the 3rd one up here. So if we now have a look at this, I've got the red marks pin there, which I believe is the ground, and we should have ground down here, Yep, 0, 0, 0. Ground up here. Yep. Ground on there. Yep. Ground on there. Yep. Ground on these, hopefully now. This is the question. Where's the ground? It's that one. Yep, ground there now. And ground there. Now we shouldn't have a connection between ground and VCC. Make it some resistance. Yeah, resistance. So that would now make sense with pin 1 being down here. Yeah, and all we've done is, all I think we've done is fix the ground. It goes that way, and I think we need to get the 16 megahertz back in. These pins here are well mangled, as you can see. So I'm now going to just straighten them. The way I'm going to do that is because they're bent right out there, I'm just going to just push it onto the table. Now, I know I've got the leg straightener, I'll use that in a minute. I just want to flatten them down a little bit on that corner, so that they're not sticking out quite so much. And then I'm going to use this actually, just straighten these pins. And it still needs a wee bit more because they're still splayed out there a little bit. And then we'll use the leg straightener, so I'm just going to press it like that. That's better. It's got a nice straight profile there now. So we'll use Cathers, and in fact that's not going to fit in it, is it? So you know what, ignore what I'm saying, you can't straighten one of those without a huge 3D printed tool. Right, so the legs look pretty good on that, I think. Let's now try and get it into the turn pins. So yeah, pin 1 is going to be down here, isn't it? And this is the thing, it wasn't that way around, was it? Certainly after you've done what I've just done, which is, in fact, this is why it had bent legs. Because, well, because those aren't straight. Whichever Muppet fitted those are sort of marginally bent outwards. So when you straighten legs, just bear in mind, there might be a reason why they're bent. Yeah, so like that side's in, it looks alright up here, but by the time you get down here, look, it's bending. Oh, there we go. Yeah, so with turn pin, do inspect, you know, down the sides like that. When you can see underneath like this, actually have an inspection just to see if you can see any pins squished out anywhere. And they all look alright. We have got a bend in that pin there, can you see that? So yeah, that's a bit strange, isn't it? We can now get the CPU out and let's just get it in and see what happens. Jumpers could be a thing now. And kickstart could be a thing now. God, that is really stiff in that. It's because it's a single wipe socket, and you know what? I know what you're thinking. You're thinking, I shouldn't be putting this in here. And you're right. Maybe I should go and get a turn pin one, because I do have some of these with turn pin sockets. And you'll know now why I reclaim things from other boards. There's nothing really wrong with the socket, other than it's a wee bit green there. You know, it was ultrasonic, so I retensioned all the pins, I think, on this one. But there is just a bit of greeniness there. But the point is, this is a dip socket, and I can plug this into the existing single wipe dip socket. These flat pins will not damage the socket on the 500 there. And then this side, I'm not bothered about, so I can stick those round pins into that. And of course we need something like this to stand it up above the ROM, because the underneath of this is going to interfere where the kickstart ROM is. Yeah, so on reflection, what I may need to do is stick a turn pin socket into that as well. Yeah, so I got that dip socket underneath and then I pushed this in. That is the most ridiculous fitting ever in terms of, you know, there's hardly anything on those pins, but it went in pretty firmly. I had to press pretty hard to get that in, and that was a good reason to use that crusty dip socket. Anyway, let's just see what happens. Let's power it on, see what happens. I'll certainly be putting my hand on here just to make sure things aren't getting hot, ready with the power supply just in case. Switch it on. Not feel anything getting hot. Now bear in mind, we've not got crystal. Yeah, it's not doing anything. It's nothing getting hot. But it's probably not doing anything because we haven't got a crystal. And this is the next question. Do we need a crystal that is exactly the right region of clock domain? I'm not going to have a 14. I may not even have a 16. Yeah, so a quick Google. We've got a picture of a crystal there. Its ground is pin 2. Oh, that's the ground. Have we got 2 grounds? Oh, hang on. Now it's making sense. 2 grounds, that would mean it goes this way, I think. Does it? I don't know. I'm getting confused. let's just test VCC. I think this must be VCC up here then. I just need to make sure that the first, where's it gone now? I just need to make sure the first pin here, the one with the dot, is VCC. If it is, then that answers everything. And you know what, I'm just having a senior moment. Yeah, that's VCC. It will repeat there, but that's, oh, hang on. No, that's ground. That means pin 1's ground. Is pin 1 the enable? Because that might be it. It's probably like active low. Let's just have a look at that diagram again. Yeah, it is. Enable, disable. And the supply is pin 14. Yeah, which is the side, the round side, opposite the square side. That makes sense. So VCC's up here, and that's what we confirmed. So you know what? Let's just stick it in and see what we can explode. And all of this may be pointless, because you know what? If it's got a bad gal on there, it ain't going to work, is it? And we're probably not going to be able to get hold of them. Although Stefan did say that he spoke to a guy in Germany on, I think it was an A1K forum, and he said he had the equations, updated equations, to use this maybe with later kickstarts, I don't know. So let's try that. It's on. It's not doing anything, I don't think. Now there are some jumpers on it as well. Do we need those jumpers on? Maybe it's like in between modes, i.e. just not on at all. Yeah, and all the while I'm just gently feeling the tops of these things here, just to make sure nothing's burning up, and there isn't. That's kind of like slightly warm now. Of course we could scope things and I could trace from where that goes now to. Might even go to one of these jumpers here. This might be the thing. Let's just switch it off. It wouldn't surprise me if the crystal output, which I believe has got to be this top right pin here, which makes sense because it comes down, and I think it goes to that jumper. You know what? That's what it is, isn't it? There's going to be a jumper on there to go, do you want to use the motherboard clock or do you want to use the crystal clock? And that's what it's going to be. Watch. I assume. Yeah, it goes to the top. So the crystal output goes here. So 3-pin jumper, it's going to be a jumper. Yeah. So in other words, you need to bridge that. The pin there is probably going to go to, I don't know, it might go to one of these, it might go directly to the CPU. Let's just see. Centre pin, CPU, so the CPU's, it's not going to be always running at 16 megahertz though, is it? So I'd expect it to go to one of these actually. It could be one of the ones that's underneath it. I'm going to try with the jumper on it anyway. Before I do that, I'm just going to make sure that 5 volts and ground doesn't go to that middle pin. Yeah, that's a useful check to do really, just to make sure we're not going to short the clock out. The crystal oscillator, that is. Yeah, it doesn't seem to go to VCC or ground. So I'm comfortable getting a jumper on it. That should mean that crystal is outputting somewhere now, versus where it was before, which was nowhere. It would have been oscillating but doing nothing, going nowhere. So yeah, grounds along the bottom here. And when I say grounds, I mean like top left's enable, that's a ground, that's a VCC, that's the clock output which goes to that first pin. So you can see my rational there, you know, my thinking that might work now. Let's try that. So I don't know, it's not doing much, is it? It's not doing much at all. I mean, I guess what we could consider here, let's just switch this off, we could consider that maybe the clock side here is wrong. Let's just pull this jumper off and put it in the other position, because I would assume that that means use the motherboard frequency. So I don't know, maybe it'll work like that. Let's just try that. See, there's a 4-pin jumper here. What's that for as well? I think the next thing I'm going to do is go find a stock photo of this and just see what's on that jumper there, because it's just, all it's doing is black screening, nothing at all, no activity of any kind. And I'm pretty confident, yeah, it's in there. It's in there firm, and because we've got 4 pins up here and then 2 on the bottom, yeah, I'll reseat that. Maybe a jumper's missing there. That would make sense because you've got 2 lots here. But I'm like, why would someone take the jumpers off it? Was you that desperate really for a jumper? Right, as usual, I don't really know what is going on. I reseated that chip and I messed around with this wire from ground to here, and I noticed that I think the clock pin was short into it. Anyway, I redid that wire and it wasn't, I don't really know what I've done. This is the thing, I redid the wire. it doesn't look like it was shorting or anything, but somehow it's now working. I'll show you. Now bear in mind it's got the cache chips removed, but it has booted. Now before that I took this out and put it straight in the socket and it worked. And I also tried before that, actually I got my 16 MHz CPU here and that worked as well, but it didn't boot when it was in the card. So the only thing I've done is measure around an awful lot, trying to follow the grounds, can prove them to myself the grounds were right all along. The wire, as I say, the only thing I could see, there's a trace that runs right, I'll show you in a minute, it runs right next to the solder point. I'm wondering if it was bridged with the smallest bit of solder. It didn't look like it was, but maybe it was. And redoing that wire, it now works. So yeah, it needed the wire, the CPU was the wrong way around, and I think I introduced a bridge to something there. Somehow it's working though. So let me just get the RAM. Let's get the RAM back in. Obviously need to get some benchmarking software, and the RAM side of things may not kick in unless you have a driver or something. Right, so I had a quick tinker with the jumpers. I didn't really get very far. In one position, one of them suddenly shot up to 14 MHz instead of 12, and you'll see that's what it reports most of the time here. So booting from floppy, sysinfo. I'll connect a hard disk up or something next, just so I can do a little bit more testing on it. So there was a freeze there. I think that might be normal. If I do speed, and it's not much faster, 10%, 1.10, and then over here, there's a bit of a pause, 12. Now that would make sense because some it's going to be running at 7, some it's going to be running at 14, I would assume, and you're going to get an average of about 12, it seems. Chip speed's a tiny bit faster as well, but I mean that's like nothing. And as I said, I changed the jumper over a little bit, and here that shot up to like 780 or 800 or something, and it was reporting 14 MHz over here, but I can't recreate that. I'll try and power it off and I'll just stick the jumper in the same position I had it before. Yeah, it was the outer row there, and it was like the second and third pins down. Yeah, same again, 1.10. So that fluke time, how did I get faster than 12? I don't know. And it really is a bit of a mystery, this, for a few different reasons. One of them, I was thinking about this, a stock 68K doesn't natively support an FPU. So I think you've got to memory map it in somewhere. Obviously there'd be address decoding for this, chip select somewhere. So one of these chips here must be providing it. And then I started wondering about this RAM, thinking maybe this RAM is for this actually, rather than the 68K. That may make sense. So anyway, let's have a go at fitting this. So I just need to just inspect the pins, and it's a 20 MHz rated part of this 6882 RC20A. So I've got to try and work out where pin 1 is there on that now. The symmetrical this is the problem. You know, you've got like 2 rows all the way around the outside and the 4 pins in the middle. So unless there's a pin 1 marking on here, I mean, we already had a scenario where someone had the CPU on the wrong way around to start with. That might be why the ground was balked. You know, we lost the ground connection to half the board here. This is deja vu, you know, echoes of what happened with Tom Meads' scan doubler, isn't it? Where a few chips didn't have a ground. You're like, how did that happen? I don't know, I think it's combinations of, you know, insertion removal where things are not aligned the wrong way around, and you get a short and some weak VCC rail point somewhere on the board just pops. That's probably what happens. And I'll tell you what, let's just have a look at the pin out of that. Maybe I can work it out from VCC. Right, I got a pin out. I'm not sure whether it's from top or bottom. I think it's from the socket. Yeah, it's upside down, that diagram. So that's the ground. Yeah, and that would make sense. So that means, well, it means we've got the ground up there. What I should do really is just test which pins are short on the chip. Yeah, so if we started there, yeah, with those are 2 VCCs, and we can confirm that they should go up here too. Hang on, VCC, that's correct. So we'll just find 2 pins in that top corner there. Let's just rotate around where they're joined. Yeah, top right too. They're joined, right. So let's just go round, around, around, just to make sure there's no other combinations where they are joined. And they're not, so we'll just keep going until we get the right combination. Anyway, hopefully you can see ways, hang on, there we go. Ways are working out. I know these 2 here are joined, those 2 there are joined, therefore that has to be the right way around. And out of all the combinations I could have guessed there, there's no way I would have thought that pin 1 was down here. because I would have tried it up here or around there or somewhere else. So let's just carefully, hang on, let's just pull this out, because then we can squeeze it in an equal sort of way, like that. Yeah, there's no way I would have known that that was pin 1. And I'm so confident, I think, I'm going to stick a red blob. So it's obvious. It's just going to power it on with my finger there. It's booting, so it's not like exploded or anything. And I'm not sure this benchmark will reflect the FPU. It may do, I don't know. I think it doesn't, to be fair. Let's just do. And this is the thing, it's not an FPU, because it's not a native FPU. And when I say a native FPU, what I mean is the CPU doesn't natively support it. So it must be a memory mapped FPU. Did I say CPU? It's a memory mapped FPU. Which means you need the software, you need the driver to be able to actually even use it. And I'm not sure how it would use it in that sense. Unless there's something in the API there, you know, the actual interface and kickstart, you know, the libraries and things that where software, you know, standard software looks for an FPU in a standard sort of way, so that if you have your own library, then maybe you could use it with, you know, software that expects a real FPU. I mean, it is a real FPU, but what it isn't is natively supported by this. So it's just a memory map device sat somewhere, a certain address, and this can then access it, you know, drive its chip select, write to it, read from it, etc. I mean, we haven't got any other type of RAM on here. Do we need some fast RAM? Would this, thinking about it, would this spring to life and give us much higher performance if we had a bit of fast RAM? Maybe I should try that, because it may be doing some address decoding on the start of the first block of fast RAM here, or in this case slow RAM. That's an interesting one. 506K of slow RAM. How does that work? Why have we only got 506K? What's happened to... I don't know what's happened to 6K there. I've never seen that before. Mind you, I've never checked before, so... I don't know, that's a bit weird, isn't it? Let's just do speed thing. I need to test that RAM out again, I think. Yeah, so it's not any faster at all, is it? It's not made any difference at all. Well, yeah, the CPU's gone even slower. It's now saying 11.6. I don't understand how we've lost 6K of RAM and we've lost 0.4 megahertz. What is going on? I mean, the main thing is it's working, it's reliable. I haven't had any crashes or any freezes or anything really. It's just a bit underwhelming, really, on the performance. It's just like it always comes back at 1.10. But now that's not showing 12 megahertz anymore. I'm not sure if that's changed since we stuck that slow RAM in. It probably is. Well, there you go, slow RAM. It's slowed it down, hasn't it? It's not sped it up. Right, so I think the next thing I'm going to do is connect up the A590. And you may think that's a weird choice, but there's two reasons for me thinking about the A590. One of them is it provides 2 meg of actual fast RAM, not slow RAM. And I think I might have more benchmark software on this setup here. So yeah, this is the point where I always get nervous with the A590. After that time the RAM burst into flames pretty much from having 2 separate power supplies. And it was this RAM went red hot. So actually I think I'm just going to put my finger on that as I power this on and just see what happens. Yeah, there we go, kickstart 2 or greater. Joy, let's see if we've got a kickstart 2 run. Right, it's getting complicated really fast, isn't it? So I need to use the adapter. I need to take this out, which is fairly easy to get out. Now it's going to raise this, so I don't know, now it may interfere with the ROM. I don't know, let's just see, I'm going to use that because it's flat. Yeah, so the hard disk wouldn't boot without Kickstart 2, so in order to fit a Kickstart 2 ROM to this Rev 3 board, I needed the adapter that I made to adapt the A17 pin. Right, I've had a number of different boards on the bench here, and I've had to swap over to the 500 Plus. I need something where a modern ROM will work in an EEPROM, and the Rev 5s, Rev 3s, you can't stick a standard EEPROM in there. you need to do the A17 mod. Now I've got the adapter, but the problem is the adapter raises the CPU, the ROM rather, right up here, which means I then need 2 more sockets on top of the socket I've already got, yeah, this one, to raise this high enough, and it's just getting crazy. I don't have that many dip sockets in that style. So anyway, let's just try this now. It's ages since I used this. It's got the PyStorm in, so I'm just going to boot it with the PyStorm to start with. So you get a pause at the start here. Sometimes I have to do this to see the LED. And this is the thing, there you go, I think it's flashing. Doesn't always boot, and for me it's all about the cleanliness of that slot there. Yeah, so the 500 Plus is up there. So let's just test it with this on its own before I introduce the A590. And this is the other thing now, that could be the next problem I don't think of. We're now using the later kickstart, it may not even boot. And this is the thing, I might actually get stuck in this situation where I can't really do much with it, can't test it much, because I don't have an old hard disk set up for it. Yeah, so that is a pleasant surprise. Right, I'll connect the A590. There'll be a video coming up on this soon actually, the issues I had when I came to test the A590 for the first time in ages, and me destroying that floppy drive at the back there. It was a bad day. Yeah, so we've got 2 meg of each there, that's good. Right, let's try integer math. That's usually a really fast one on CPUs where you do a basic overclock, switches itself to the slower clock domain most of the time when it's interfacing with the Amiga side of things. It's taking ages. Right, I stopped the camera there because I thought it had crashed, and lo and behold, it did come back. So, where are we? Well, just like a 600 really, aren't we? There's hardly anything in it. There's like a sliver, 1 pixel or something in it there. You know what, I'm calling this accelerator crap. Back in sysinfo, make sure it is still showing like the 12 or 11.6 or whatever it was reporting. I mean, it's in the 500 Plus now, so I'd be interested to see what it reports here anyway. Oh, it's actually quite a lot faster now. Now it's saying we're 1.47 times faster. It's still showing 12.3, and this might be because we've now got some fast RAM. I don't know. But I mean, that's still, it's not doing much, is it? When you look at something like the TF520, the 520's better than that. Didn't that come back 1.7 something? I'm sure it did. And there's literally nothing else we can do, is there, benchmark wise? I mean, I can test the speed of the drives, but I don't know how that's going to... Well, let's see how it fares. So 928, that's not bad actually, it's a bit faster than I expected. So yeah, there is an improvement there. 47% increase, not rocketing along, is it? At the moment, I don't think we're gaining anything from this RAM, and we're not able to use the FPU. So I think we would now need to install a library that provides FPU via library access. Yeah, so if you've got software that looks for the library, and this is the thing, do they do that or not? Do they just look normally straight at the hardware? If you've got an 030, does it know where to look rather than actually looking for a library? Right, I found the disk masher file. That's like a .dms file if you're not familiar, and you can write those on Amiga. So I made a copy on a PCM-CIA interface, compact flash card, onto the 1200, and then on the 1200 wrote it to a disk. So here we go. Let's see what happens with this. This is the thing. What's the Mac 2 stuff, Avanti stuff? Is that specific software? You see, we've got no manual FPU in it and FPU mod. I mean, is Mac 2 the right thing? I don't know. Let's just try it in it. That says, okay, check FPU. Well, it's frozen. Maybe it's checking it, I don't know. It's showing 14.1 there, 13.79. It's almost 3 times faster than the stock CPU there. It doesn't boot without the cache controller, so that seems to be integral to it. I think there is caching going on. The FPU I just can't enable. I just can't get it to work at all. There's 2 sets of files on that disk, 2 lots of libraries, 2 lots of tools to test it. Neither of them work in any combination of the jumpers. You can see an example there when I loaded it there. It comes up saying FPU function error. That's the Mac 2 one. I tried the Avanti one. It says no FPU detected. So this makes me think it's detecting it, but there's some issue. Now, whether it's library incompatibility with Kickstart 3.1, I suspect that's what the issue is. It could even be needing a change on the PALs, actually, the gals, because Stefan did say the guy he knows in Germany has got updated versions of the JEDEC, but he wouldn't give it to Stefan, so, and I don't know who he is. So even if we could get hold of it, I'm not sure whether it would, I'm not sure what the purpose of it is the point. Yeah, and I've tried every combination of jumpers here. When the jumper was down at where it was here, you know, it was like marginally faster, wasn't it, like 10%, yeah? And I'm not quite sure why. You might expect the 10% if you had a 68010. That's not what this is, it's 68,000 P16. So that's the first strange thing. But when it's up here, that's where I've got the, you know, 2.7 times, roughly 2.6 times faster than a stock machine. And in the benchmarks, it actually shows it running at 14 megahertz. I swapped this RAM. You can see Hyundai RAM on there, so I'll just power it off. Yeah, I just ruled the RAM out by swapping it over. Let's just try it with no RAM, and then try it back with its original RAM, and just see if it still continues to work. Let's just try it with no RAM. Yeah, it's not booting again. There's a balked trace there. Now, is that a deliberate trace cut at manufacture? Yeah, so we just got an error there, which is interesting. Yeah, it went round 15 times. Let's just do that again. And yeah, I'm not ruling out something to do with this 500 Plus, a bad connection or something, but yeah, so it seems occasionally to flake out just a little bit. And it could be dirty connections on the actual pins because they're going into a socket, which is going into a socket. That's a factor as well. But anyway, yeah, generally it runs pretty well. Stefan helped me out with another copy of the manual in English, and I went looking at the forum. He'd been looking at A1K forum. And there's a few different things. There's simply a later version of this card with some dip switches. And from what I understand, there's one with a big gal or something, which means, I don't know, the gal's been updated or something to work with Agnes's that have more than half a meg or more than 1 meg. Probably more than half a meg, because the manual I was looking at seems to indicate you need an 8371. All of the little things in the table about the jumpers, and that's a bit cryptic, I'll talk about that in a second. It suggests combinations of like 512K chip and then different amounts of fast RAM, as if at that point in time there was no 1 meg chip. So that could be an issue. The jumpers at the moment, I've set the middle one on here. That one's just hanging over the end, it's not actually on. And the one down here is down, otherwise the FPU doesn't get a clock. If you've got a crystal in here, you move this black jumper here up, yeah, to the top position. So I've worked out, I think, that when that's in the middle, there, the red one, middle of the 6, you know, pins 3 and 4 bridged effectively. With this configuration here, with a 2 meg chip Agnes and 2 meg fast RAM, it runs really fast. And other than that error you saw a minute ago, where it went around 15 times, I mean, I used it for half an hour, I didn't have a problem at all. But the FPU is still doing that not detected thing, you know, not responding correctly or something, incorrect initialization. So I'm left with the dilemma: is it the libraries? Is it Kickstart 3.1? Is it the fact that it's got more than half a meg of chip? I think I'm going to go back to that Rev 3 board with Kickstart 1.3, stick it back in there, boot from floppy, you know, boot workbench, and then stick this disk in and just test the FPU again. Right, so I've pretty much exhausted all options here. Testing with the 10 megahertz crystal here. The clock comes out here on this pin. I'll show you on the scope, 10 megahertz at the moment. As you can see, I think the chip select for this chip, the FPU, is just tied to ground. I tried a one-shot capture on it. You know, you change the trigger, and then you go into trigger. You change it from sweep to single shot. And yeah, he never changed state, and then I realised I think it's just grounded. I've seen other designs that do the same thing. But the fact that when you try, you know, you run that init software, if the clock is missing, it just sits there waiting. It's looking for it. Yeah, that shows me it is actually communicating with the FPU. You know, the correct addressing, I think, because it gets no response. As soon as the clock's there, you get a response for it says FPU failed in it or whatever it is. 3 different FPUs, you know, 10 megahertz. I mean, I'll try another one at 10 megahertz because you know what, maybe that one's balked. And without a dedicated crystal like this, you're running at, switch it off, you're running at a 14 megahertz, and these aren't 14, one's like 12 and one's 8 or something, or 10. So you know what, maybe that FPU's dead, let's just give it the benefit of the doubt. But again, we're back to the fact that it's responding. Yeah, we know that because the clock is responding with something. Well, yeah, maybe it is faulty, it's responding with the wrong thing. And so let's try that. But if this doesn't work with either of these two, we will have exhausted all options. And I think it's all about that software. I think that software is a later version. Well, I know it is. It comes up saying Mac 2. Now this is Tornado. Yeah, I was looking at some of the later, one of the later manuals. I can show you some of those up as screenshots while I talk about some of the stuff. But originally it was called Tornado, and then later they ran into some sort of copyright issue because it was a, I don't know, a patent or trademarked name. So that's why they changed it to Mac 2. I'm not even sure if the company name changed hands, because there's a few different things that are different between the different sets of documentation. And it may have got outsourced to other companies, this product. I honestly do not know. The bottom line is, I think the set of software I've got here, the disk, I think relates to the later model. And the later model had 4 dip switches, and it was subtly different, but generally the same design. It was just that I think maybe it's just the dip switches, I could be wrong. Maybe there was just one set of software. But looking on the A1K forum, I also found users saying exactly the same thing that I'm seeing here, that they got this FPU init error. And that could be a common fault. I don't know, I don't think so. I also checked every data bus connection on that FPU to the CPU socket. Now they don't go in the order you would expect, so it's not like, I don't know, D9 goes to D9, they don't. They're a bit odd, but every single data bus connection went to the data bus on the 68K socket. So, the libs are installed here, by the way, on this version of Workbench, so I don't really know what's going on. FPU function error again, look. And now we're running at 10 megahertz. I've scoped the clock on the socket, so I know that definitely got the jumper right there. And I'll show you that jumper in a minute. I'll try the other one, but I don't think that's going to work. Don't say I didn't try more or less everything. Obviously I'm booting Workbench 1.3, but I don't know, I think at the very least, if it didn't support Workbench 1.3 with a Kickstart 1.2, that would be, the most ridiculous thing ever, I think. There's something therapeutic about seeing that blue Workbench screen. And the disk drive as well. I've got an external drive to build at some point, and I'm going to miss the actual physical drive noises because the drive I'm going to be building is, there you go, FPU function error still. It's based on a Gotek. I will just investigate these wires as well, just compared to the photos, to make sure it's the same as the ones online. I saw a photo with one of these without that chip there. If you test without that, it won't boot. So that's a weird one, and that's without an FPU as well. It still won't boot if you've not got this chip, and it won't boot without that RAM, won't boot without that. So this is for the cache in here, I think. I'll try and look that part number up in a minute. You've got an XOR down here, probably just for clock stuff maybe. I haven't checked the resistors, but I can't really see those being the issue. We were missing a ground obviously at the start of this. Could that have killed something? Well, yeah, technically it could have done. But I don't think everyone's going to have a bad ground, and like I say, I saw one or two other people with describing the same symptoms as I'm seeing here. They like it working, the clock getting there, but the FPU failing to initialise. So yeah, it could be a common fault, I don't know. But I think it's about the software actually. So up here, I was right at the start when I was like looking around here going, that's for a crystal. And then I worked out this jump here and thought, that's for the FPU crystal, isn't it? And that's what it is. When it's in the top position here, 1 to 2, you're using the crystal. You remove the crystal, you can get it off. And like I said, I tried a few different speeds. And then the jumper wants to go down. And if you have it up like that now and test it, when it comes up for the FPU init part, it just sits there. It waits forever and ever and ever, and that was where I was like, let's try changing this over in real time. And if you do that, bing, as soon as you touch it, bang, it responds. So that shows me that it is communicating with this. There's some issue though, isn't there? Maybe You see, the thing is, there could be different revisions of this, like the data bits might be wired differently on this, and I'm trying to think, would that actually be an issue? It probably wouldn't, because this is not going to be aware, you know, it is in terms of instructions though, isn't it? What I'm thinking is, if you say you had a couple of data bits flipped around because of the way this earlier board was wired versus how the software's interacting with it, when you're writing commands to do various things and then reading the data back, you're going to get an unexpected result because, well, it's not going to do what you want. If it's not there, you're going to get a different result completely. You're going to get, you know, it's just not responding. So, yeah, it could be something like that. Like I say, that the software, that the hardware was revised with the later board and the software was revised. And we've got software for the newer board. That's what I think. So the jumper's here, and I'll show you the screenshots of the instructions here. They're pretty bad, and there's a few different ones of them actually for the different revisions. But nevertheless, this one with the 6 pins, you use these jumpers here. It's like 3 lots of them. You have, like, you know, 1 to 2, 3 to 4, 5 to 6, depending on how much chip RAM you've got and how much fast RAM. And the table just seems to list 512K chip. It doesn't mention any other combinations of chip. And yeah, that's a complication as well, isn't it? What happens when you've got, like I did before, 2 mega chip and 2 mega fast? Well, how do you set the jumpers? The table doesn't help you. You just have to go to the maximum setting, really, and say, well, I've got 3 meg, because that's what that table went up to, 3 meg, I think. It might have gone up to 4, I don't think it did. So when this came to me, obviously that jumper was down here, and it was performing pretty slow, like 10% faster than normal. You put it there, and in that position on this board and in the 500 Plus with its 2 mega chip, that's where you get, you know, really good performance, like over 2.5 times as fast as a stock CPU. So in that respect, it's functional. It's pretty good. This, you know, I could just remove the FPU, and then it's useful to stick in a board like this, and you'll get just over 2.5 times the performance. But the question then comes back to this jumper here. If he's only capable of doing this cache, you know, the running full speed here within a certain address range, you know, a certain amount of RAM, window of RAM, then when you've got more RAM, what happens when you get into that more RAM? It does just go right back down to, you know, 10% faster than it should be. It probably does. And I'm also still not clued up as to how is it actually caching anything in 16K here. The way cache works is, you know, it's just that small block of data you're looking at that point in time, so you're going to be, you know, going forwards and backwards a bit in a, I don't know, a 2K block, 4K block, 8K block of code as you run through, and that's where you get your massive speed boosts, your optimizations. But it can only be in one direction. You know, it's not like you can, well, yeah, it can only be in one direction. It's only reads where you gain, isn't it? Writes still need to pass through to the main memory. You could argue it would have made more sense to have done what they did, and I'll stick a video link top right on that little booster I built. I forgot what it was called now. I'll stick the name top left as well. That little red one that had, I think it was 1 meg of slow RAM that was actually fast RAM that was local, yeah, and it could run at the full speed all the time. So yeah, you do that, you run even faster really. But of course then you get compatibility issues perhaps. Anyway, I'll do a little bit more testing off camera and I'll report back in a minute. And now we've got that extra slow RAM, it's running really slow again, literally just over 10% faster. So like the middle position clearly isn't right, so let's now try the bottom position. See if that makes a difference. Yeah, look, 1.1 again. So like, why is it now slow? I don't know, but now it's running slow again. Let's take the jumper off, no jumpers on. It's bizarre, isn't it? It's like, how does slow RAM slow it down? Well, it's in the name, isn't it? It says there, look, slow RAM. Right, trying the other combination of 1 to 2, 5 to 6. That seems to be the only pretty much combinations. You either have the middle one on, or you have the outer ones. Or maybe one or the other of those. Yes, there's not very many combinations when you've got 3 lots of jumpers like that. You know, it's still 10%, look. Yeah, I think the answer is in the slow RAM. If you add slow RAM to one of these systems, obviously it runs really slow and then you gain nothing. Yeah, 10% again. So you've got the question, you know, what was the point in this back in the day in a 500 anyway? Because most of them would have had slow RAM here. It's running slow again, isn't it? I know it's not, there we go. Yeah, we're back to, you know, twice the speed there. 1036 dry stones, you know, it's pretty much twice as fast. But of course it runs even faster, as I say, when you've got actual fast RAM, because fast RAM is going to run faster than chip RAM with something like this, and anything's going to run better than slow RAM. Right, so it just wouldn't work on the 2000 at all, really. It's strange, isn't it? But then again, one of the problems you can have is when you use these adapters on the 2000 with anything, certainly the 68K, it can be super flaky. You know, and it's all about the location. You know, when it was spec'd to be here, signal integrity and stuff is different with one of these, yeah? With something like an 030, you know, there may be additional buffering on a design like this. I don't think there is, actually. Although, yeah, there is for the RAM and stuff. But it's been designed a different way, and you've got different drive levels on lots of the signals and things, maybe, versus something like that. It's not going to be exactly the same. So yeah, if you take one of these adapters and stick a stock 68K in, it's going to be really hit and miss. Yeah, you stick your 68K there, you're all right. Yeah, it's just all about, like I said, what it's been designed for, you know. So this may run a lot better on one of these boards when it's in that position there, but you've got all this stuff around here. I'd need to get a bunch of sockets there to raise that up. I don't really see the sense in pushing that any further. I may have a tinker with this a little bit more. There might be a follow-up, I don't know. Because at the moment, obviously, we haven't got the FPU doing anything apart from being detected and then said it's failed to in it. As I say, and I'm more confident now in coming to the conclusion there's nothing wrong with it. I do think it is about the software. But digging into things a bit more, I was like, you know, this, as I said, a cache controller, because that's what I thought it might be. Yeah, and it is. It's actually tag RAM chip. Yeah, so I was looking at the specs of this and managed to find the datasheet for this. You can still buy these from UT Source. They're about £7 each, roughly. So I don't know whether I want to invest in buying one as a spare or two. I don't know. But then I was trying to understand, you know, how this works in terms of how much space, you know, how much it gives us, and, you know, how it works specifically. So tag RAM is SRAM that stores the address, yeah, the address of what is written to and read from these RAMs here. So it's SRAM that's got some address comparison logic in there. So, you know, when an address is set by the CPU as it's about to read the next instruction from RAM, for example, straight away that is going to do a match or no match based on the addresses it has cached within there, yeah. And if you get a cache hit, it will then read straight from this RAM rather than have to, you know, wait states and stuff and have to wait for, you know, the motherboard to return the RAM. Yeah, that is in summary how it works. So you've obviously got a limitation in how many, you know, the size of your address window. Yeah, and it's going to be, if you think about it, the address is changing constantly, aren't they? Yeah. But you've got this address window, so how many address bits are on here? Well, it's 8K, so you've got 8,000 possible locations that you can actually cache, which is why we've got two of these. So I was like, well, these are 8K each as well. How does that make sense? Well, remember, it's 16-bit, yeah? The 68K here is 16-bit. You've got a 16-bit data bus. So when you want to cache a value of data in RAM, yeah, it's not 8 bits, it's 16 bits. So you need one for the upper byte and one for the lower byte. And this is keeping track of where that byte was read or written, you know, to. Cache hits are going to be, you know, obviously you gain in terms of reads, yeah? It's where you're rereading something. And the general idea is, you know, because this is not caching every single location. Otherwise it'd be a whole complete second copy of the RAM, wouldn't it? It's just caching the last 8K of hits, effectively, you know, or not really hits, the last 8K of accesses, yeah? So that's constantly going to be, and this is the thing, it's going to constantly get updated, isn't it? What I'm not sure about is where you decide to reuse an address. This is the thing, it scrambles my head thinking about this, it really does. I think the thing is, you see, what you've got to remember is there's only a certain amount of bits in terms of the addressing on this. You know, it's not 24-bit. Yeah, if it was 24-bit, we'd have sufficient RAM on here, you know, for the full 8 meg address range, and then it would cache everything. It'd be like lightning fast all the time. And then you could argue, what's the point? What's the point in doing that? It makes no sense at all. It's like a second set of the RAM. But when you're progressing through code, the way the CPU tends to work is, it'll progress a few instructions, then it jumps back to where it was. There's like a bit of commonality in its vicinity. It kind of jumps around a bit in the same local block. It could be within a 1K range, a 2K range. Occasionally it'll jump right out that range and then into, an area where the cache is not being hit at all because you're on totally new code. And then the thing I'm not sure about is how does the cache then get repopulated as it's going along. I don't know. It's like, it's a complicated subject, but it's really simple. This is the thing. But the key here is that can hold 8K of addresses. And then for that 8K of addresses, we've got 8K of 16-bit data here. Yeah, just confuse things. 16K, really. 8, 16. So, yeah, that's quite cool. And it's a military spec part of this, actually. I was looking at the datasheet again. Military spec. Yeah, 35 nanoseconds. And actually, the 35 nanoseconds is this part, that's what it's marked with. But the actual individual functions vary a little bit. And I think there's a few different flavours of this. So, like, I don't know, like the chip select time can differ slightly. And, reads can differ to writes, etc. But, yeah, overall, that's rated 35 nanoseconds. Yeah, they must have been fairly pricey, those, when that came out. So I guess it kind of makes sense now with these, and this is the thing, it makes sense, but it doesn't in some ways, that these crazy jumpers here, what are these doing? These are shifting around, I think, is it 12, 11 or 12 address bits here? And which address bits do you use? Do you use the lower ones? Well, you need to think about what you're addressing. It's probably going to be the upper ones. So certainly some of the most uppermost bits are going to relate to specific regions of RAM, like chip RAM, fast RAM, etc. Because, you've got quite a large memory map there, 24 bits. We haven't got 24 bits. And I think these are going to be used to shift that around into different regions, maybe, because the table in the instructions, that we couldn't really read, that were in German, that seem to contradict themselves between different revisions of the manual. It's not as clear and concise as it could be, is it? I would have preferred if there was some, I don't know, address ranges written somewhere, a table of them or something, because then you could kind of make sense of things. But the way these work, I had to just faff around with them. There's a lot of, it's just trial and error with the three, and I think it's 3 different combinations. It's 1 to 2, 3 to 4, 5 to 6, I think. Yeah. You set one of these one way and then suddenly it doesn't even boot. And you're like, well, how's it not booting? All we're doing is caching stuff here. And presumably it's not caching writes. It can't be caching writes. Well, maybe it is caching writes, but what I mean is, surely the point where it writes something, it gets cached, but then it writes it to the board. I honestly don't know. It's a simple subject, but it can be quite complicated on the, depending on the architecture of the system. When you've just got some RAM, and all this is doing is interacting with RAM, you can cache pretty much every single thing, can't you, in both directions, without any issues, and you don't have anything to be concerned about. But when you've got, chip RAM, yeah, and you start trying to cache chip RAM, and you've got Paula doing writes to that chip RAM, yeah, your CPU hits the cache here, well, you haven't got a copy of it, unless this takes that into account and is capable of, updating here when the CPU's not the thing updating the RAM on the board. Do you see what I'm trying to say? So there's certain things you can't cache, or have complications caching. Just had another quick look at the datasheet. I really should stop guessing off from my memory when I'm trying to talk about these things. When I said 12 bits, well, that wouldn't make sense for 8K, it's 13 bits. Yeah, it's A0 to A12 in terms of address lines on this RAM chip here, this cache tag RAM. The way you can calculate, if you want to calculate when you've got so many address bits, how much space you've got, it's 2 to the power of however many address bits there are. So, in this case here, we've got 13, 2 to the power of 13 gives you 8192. So that's our 8K. Anyway, the point here is just to work out where these are going. Yeah, and I've got the wrist strap on, but I am on a non-safe surface. But nevertheless, just testing from these jumpers here, so I thought, let's just test the ground first. So we go down here. Here we've got ground, ground, ground. So yeah, the tops, there are 3 sets of jumpers here. It's ground, ground, ground as the first pin on each. Yeah, and then the other ones I measured on resistance. Now you can't see this, but I'll describe up to VCC. So I'm measuring, you know, from the VCC pin on the 7.4 series here to the actual pin, and I've got 3K3, the fourth pin down, 3K3, and the last pin, 2K2. It's interesting that one's different, but anyway, if I then test connectivity, the two 3K3s are down here. So if we go from the second pin, that one, that's that one, yeah, the inner one, and the fourth pin down is that one. So those are the pull-ups for the first two jumpers, and the bottom jumper, the 2K2, is this one up here. Getting confused, it's this one over here. Yeah, so that's the 2K2. It doesn't really look like 2K2 from this distance, if I'm honest. So just to summarise, the pull-ups are those two there for these, you know, first two jumpers, and then that one there for the bottom one. So the next thing is to just work out where they're going. Yeah, it's going there. Setting from the end. The next one down. Let's hope these are logical and it's like nearby, not on a different shape. And that may make sense because we might have a different bunch of address bits going to each of these. Second one again. So actually it's that one there and that one there. Different, you know, it's the top on that one, isn't it? It's the actual, you know, it's the opposite around the chip. You know, those are opposites. Anyway, so we know where those are. What about that last one? Yeah, the last pin. Yeah, so two of them go to there, don't they? That chip. Now it does have me wondering what those two chips are doing, if I'm honest. I guess what we should do is just take the CPU out, because if we take the CPU out, maybe we could see where they're connected. I mean, this XOR down here seems to be doing very little. Looking at it, there's a few connections on this side. Buffering clocks, I would have thought, the sort of thing you tend to find. But it might, one of the logic signals may be going through here for something. So yeah, anyway, pin 1's down here, isn't it? So we've got data bits here. Let's just see if any of these data bits go to any of these. It's probably going to be address bits and bus protocol stuff. Yeah, so no data bits are going there, I don't think. So it's got to be address bits, and I forget where the address bits are. I think they're up here, aren't they, some of them? Yeah, 13 up on that side there, that was A23. So it's working, it's operating on the upper address bits. Maybe it's working like a page type mode, you know. These must have like a connection to these, presumably. And at least one of the inputs on these is set by the jumper, so that you know, you're setting the comparison, really, the address ranges you want to operate on, I think. Some of the stuff here might be to do with the FPU now, thinking about it as well, because you know, this is memory mapped, isn't it? Presumably, you know, there's no FPU chip select or anything comes out on here. This is, they've plonked this somewhere in the address range. I don't know where. And this is the other annoying thing with this, is why is there little information about that in the actual manual? Why is it not saying, you know, this sits at such a place? Yeah. It doesn't do that. You just get a library and you're left wondering where it sits. I mean, if that was publicised, I could actually maybe reverse the library. We could actually have a look at the library code, see if we could hack it, because the library may not match where this is actually sat at the moment. And of course, this is where a fault on one of these, something to do with the address decoding here, could be the reason why that's not seen. But the very fact it sits there waiting for a clock shows me that it is actually communicating with it. Interestingly, the data bus is joined up on this. It's a 32-bit, that. Yeah, it's got a 32-bit data bus, but they're all doubled up. So, you know, like if you look at D0, for example, it connects to 2 of the data bits on there. And I think there's like it might be the size pin or something, is it, that you can, you know, set whether you want it in 16-bit or 32-bit, and I think that's set, you know, hardwired that way. So of course you're going to get better performance with something like that alongside an 030. Right, and with the help of this, it's easy to test data bits and address bits, isn't it? Because they're all labelled on here. So yeah, I've just measured, and some of the connectors up here on the gal that's under there, they start at was it now 23, all the way down to A19. Yeah, and that's it in terms of address bits there. I tested every other address bit to this chip and that one, and I couldn't find anything. So that's interesting, isn't it? So like this chip here is doing the main address decoding, it would seem. Now one of the jumpers went here, two of them went to there, didn't they? It was the M2 pins, I think. So it makes me wonder if that's something to do with this and the chip RAM. This is what I'm trying to get my head around. What are the three individual bits doing here? Well, two of them are affecting, let's say, the address bits, you know, the match on addressing between A23 and A19. So a couple of those bits must be toggling there with that in terms of, you know, when it does the caching. It's this third one here. Why are there no address bits going to that? So I need to just double check that. So the bottom and the top ones are primarily address decoding. That would make sense because that table said 1 to 2, I think, and 5 to 6. So those the bottom two is where it's shifting the address range around. And we've only got, yeah, we've got 4 combinations with that, because we've got both of them off, both of them on, and then the alternate versions of, you know, on, off, on. So 4 different ways the address mapping can work there. But that middle one, what is that middle one doing? Well, the middle one is going down here, isn't it? The middle one. You know, and this is what makes me wonder if that middle one's like an FPU enable, actually. Because I'm not really sure what the middle one's doing. Yeah, and the FPU chip select is coming from, hang on, yeah, the third pin down on there. So that is doing the chip select for that. Right, and I found another problem by doing this. I was like getting inconsistent connectivity on this pin. Let me show you. It's this one here. Hang on, or is it that one? No, it's that one. Yeah, I was getting inconsistent connectivity, look, right? So I've got a firm connection on the gal, look, I'm pressing now, I've got to join. Yeah, just watch when I press around this pin here, different ways, hang on. Seems to have joined up now. I actually think where it joins the trace on the top side there, it's a bit fluffy. I think what I'm going to do, I'm going to test this on a 500 Plus again, and we can, now we know which pins it is. It's like the second one here, and it's, I think it's these two up here, isn't it? We can actually logic probe those when the jumpers are on, and we'll know whether they're actually working or not. Yeah, I've got my red mark to clean off there, but I did clean this up previously. But anyway, just for good measure, I am going to just reflow each of these pins here. Just give it a second or two. Yeah, it's not made any difference. You can see what I mean here as well. So I mean, the moment I've got the bottom jumper on, yeah, I tried with the middle jumper, it wouldn't even boot. And doing a speed test there, you can see we're just, well, we're at stock pretty much, 1.05. I mean, it's saying 11.7 there, but we don't see the same boost we saw on the 500. So let's get Liv2's board in, set to 4 meg. Now it's relocated into fast RAM now, so is this where it's going to, well, it's gained a bit, 1.4 now. Oh, it's frozen, look though. This is the thing. Right, I'm sure you'll be relieved to hear we're at the end of the video here. I'm sure that was long and arduous to watch. It was, trust me, it was long and arduous to edit as well, like 3 days of editing. So yeah, the top and bottom of this is, strangely enough, this worked really well on the 500 Plus with its 2 meg of chip RAM. It's not supposed to. It's supposed to need a later version of one of the gals here, yeah? The FPU, we don't still know what's wrong with that. I'm going to do a little bit more testing. We might do a follow-up or something. Maybe one of the data bus connections is not right somewhere or something like that. It could even be these mods. There are 3 factory mods here. I'm wondering if those do not correspond to the software we're using. Maybe this is like a really early one where, I don't know, the software is different. Yeah, there's still a red mark there, but I cleaned this up. We reflowed those jumpers. It needed the ground wire. This was in the wrong way. That's probably what blew the ground connection. And of course, it didn't have any jumpers here, so we've got, you know, a jumper there for the FPU. We've got those jumpers, and it works really well when it's in the middle On the 2000 here, when the jumper I think was in the middle again, and I had fast RAM, yeah, we did get like a 47% speed increase, and it was glitchy as heck, as you just saw. But then the other question there is, why was it not 2.6 as it was on the Amiga 500? And I think it's because somehow, even though when this was designed, it was designed for an 8371 where you had 512K chip RAM, we've got 2 mega chip RAM in the 500 Plus. Some of that chip RAM was being cached, and it was working, but how reliable that would be, I don't know. I think when you start loading things from floppy, I think problems would start or something like that. So you know what, it's pretty useless in today's regime of amazing Amiga hardware. You can't really use something like this these days. You could stick it in a really old spec machine, but you're not going to gain much. But it was very interesting, I think, from my perspective, to look at this cache stuff here. Anyway, I do hope you found the video interesting. Massive thanks to Stefan. It is a prized part of my collection. I will do more testing off camera, and if there's anything else to report regards to the FPU, I'll report back. But if you've got one of these and you know perhaps you've got an insight into what problem I'm experiencing here, post down in the comments below. Thanks for watching. If you'd like to support the channel, please see the Coffee and Patreon links, and I'll catch you in the next video.